Welcome to section 9.1, identifying quadratic functions, and this is the second video that we're doing, and it's going to be focused on vertex, domain, range, and minimum and maximum to an extent. So this is a lot of words that you've never heard or you have heard only just briefly in various conversations in math classes or whatever else, but vertex, domain, and range are all going to be added to your words worth knowing, so hopefully we will get this little bit of vocabulary taken care of during this section. So let's start with this. So big question that you need to ask yourself is, when will you know if a quadratic equation is going to have a parabola opening upwards or opening downwards? So is it going to look like, whoa, I totally messed that up. Is it going to look like this with arrows pointing up, or is it going to look like this with arrows pointing down? When are you going to know? Well, if you have your equation in this y is equal to ax squared plus bx plus c, so y is equal to all of the quadratic function stuff, then if your a term, if that number out in front of that x squared, if that is above 0, then your graph will open upwards. So here is our example. We have the number 4 in front of our x squared. 4 is a positive 4, so it is opening up. That a, we can make this actually make sense. So 4 is greater than 0, so therefore it opens up. I'm going to, oops, pick the wrong thing. I'm going to not erase that. Now, this other side, let's think about this. We have 2x squared plus y is equal to 5, and you might say instinctually, well, the 2 in front of the x squared is positive, so therefore it opens up. But you need to be specific. You need this y equals ax squared plus bx plus c format. If you don't have y is equal to everything else, then you have no ability to say if it's going to be opening up or down. So do a little bit of math, subtract 2x from each side, or 2x squared from each side, and you will end up with y is equal to negative 2x squared plus 5. And if you see then, wow, I have now a negative 2, and if I were to put that into this a here, negative 2 is less than 0. Yes, that is true. So it's going to open down. This is important just simply for your own graphing sake, and if you're looking at an equation and if you're getting numbers that are making it look like everything is going downwards, but your function is quite clearly a positive number right there, this should give you a little signal, crap, you are graphing this incorrectly, or you're finding the wrong numbers within the table. Your math is a little off. So pay attention to whether it's opening up or down. This leads me to the whole concept of the vertex. The vertex is essentially the turning point of the graph. So if you noticed on parabolas, they have two things going up at the same rate, or they have two things going down, or not at the same rate, but they're going down quadratically or up quadratically. And based on that, the vertex is this turning point where everything switches. It goes from up to down or whatever else. So it's either the lowest or the highest point on our parabola. And that parabola is that nice smooth curve, if you remember from the last video. Nice smooth curve. So in this case, if we look at our first case right here with the parabola that's opening up, first of all, we would know that this is opening up because it should have a positive first coefficient with that x squared, that number at the front of the x squared, that coefficient should be positive, and the vertex is at 0, 0. As well, we can look at this second graph, and we can find the vertex. It is at 2 axes, or 2 over on the x-axis and 1 down on the y-axis. So 2, negative 1 is where that vertex is. So let's check this out. Our minimum or our maximum depends on our vertex. So this, I'm getting into some pretty crazy stuff. Minimum or maximum, so the highest or the lowest point on our graph, is all dependent upon the vertex. And you're either going to say a graph has a minimum or it has a maximum. It cannot have both in terms of parabolas, because if we notice right here, these arrows show you or should indicate to you that that graph goes on forever. That parabola will go on forever. So those arrows do not stop. So there is either a maximum on a graph, or if you had a graph that pointed upwards, there is a minimum on a graph. So let's look at this graph right here. We have a parabola. Let's first, what is the vertex? Let's identify the vertex. If we look at the vertex, it's right here. So what point is that? What coordinate pair is that? It's over 1 to the right on the x-axis, so it's 1 on the x, and it's up 1, 2, 3 on the y-axis. 1, 3 is that point for the vertex. And now we need to give the minimum or the maximum. And when you're talking minimum and maximum, we are only talking about the y on this. The maximum here is y is less than or equal to 3. So y can equal 3, but it can also be any numbers less than that. So that is how we are going to notate that. The minimum or maximum is going to be a y is less than or equal to a number, or it's going to be y is greater than or equal to a number. So give the minimum or the maximum. The maximum in this case is y is less than or equal to 3. So let's go on and do a little bit more. These are some more interesting words for you. Domain and range. And if you remember from our function unit that we kind of screamed through chapter 4, I think we actually touched on like 3 sections, but we screamed through it. Domain is technically all of the x sides of the coordinates, and range is looking at all the y side of the coordinates, so y versus x. What's interesting with parabolas, and if it's not going to be a parabola unless it can do this, is the domain of the parabola will always be all real numbers. So if you ever come across something or someone who says this is a parabola, but the domain, essentially any x value that you put into that equation, if it can't be any single number in the entire universe of real numbers, so -1, -0.5, +14, a million, whatever, if it cannot be described, if the domain cannot be described as being all real numbers, it is not a parabola and it is not a function. Or it's not a parabolic function, it's not a quadratic function, and that's just how it is. So what's nice is with your homework that you're going to be doing is you will have a gimme for every single one of these types of questions that asks, what is the domain? You are going to simply write, if it is a quadratic function, you will only write that it is all real numbers, and that's pretty awesome. Now range, we're talking about the y's. We're talking about all the y coordinates. And if you notice on a parabola, there's a minimum or a maximum. So this range should essentially show you the minimum or the maximum. So essentially for this one, we have 1, 2, 3, 4. It's up 4 on the y-axis, and it doesn't go above that. So you can say y is less than or equal to 4 for this particular situation. So the range is all dependent upon the minimum or the maximum. So if you look at the vertex, and if it is going up or down, you should be able to determine the range and be able to say if it is a positive number, a negative number, and if it is essentially opening up or down with that statement. So y is less than negative, or y is less than or equal to 4 tells me that all the y's can't cross this point of 4, but then also it's all of these numbers below that. So therefore it is all numbers that are less than or equal to 4. I hope this helps. Start on your homework. Your homework should go fairly quickly for this section. If you have any questions, please call or email. I'd be happy to answer your questions. I'll talk to you later. Bye.